Okay, YouTube, this is my first video in my module on graphing, linear and nonlinear inequalities as well as systems of inequalities. And so what we're going to start with in this video is essentially this idea of what a linear inequality might be and how we might represent its solutions. And so we've seen that equations in the form ax plus by equals c are straight lines when we graph them here. And so those are equations. When we talk about a linear inequality, all we're really doing is taking this equal sign, we're changing it to a different type of comparison relationship. So either say a greater than or less than, or we can have a greater than or equal to, or less than or equal to. But this would give us some, I suppose, if we were to write it like this, ax plus by is, say, for instance, less than or equal to c. This would be what we call a linear inequality. And so with respect to what we're talking about with these things, we're often on and on about the solutions to such a graph here. And so we could see that, solutions, those are the things we tend to graph when we do graph say an equation or an inequality. And so it says here, we know that the graph of an equation, okay, and just to be clear here, an equation in two variables is the set of all points whose coordinates satisfy that equation. So that is to say, like if we were to graph this blue line right here and take any of the points on that line and plug it back into its original equation, we would get a true statement. So for instance here, 1, 1, if you plug this back in, you get 1 plus 1 is 2. Or if we said 2, 0, that's 2 plus 0 is 2. Or if we said, positive 3 but negative 1, add those together, it's 2. So when we talk about an equation, we're saying that all the points on that line are the solutions to this. When we talk about solutions to a linear inequality, what we need to acknowledge is that the solutions don't just include sometimes the points on the line, or maybe sometimes it doesn't include the points on the line, but it includes all the points on one side of that graph or on the other side of that graph. So we say here that a half plane is the set of all points on one side of a line. And so when we sketch a graph of a linear inequality, what we're essentially going to be doing is sketching the graph of the line if we were to treat this as if it had an equal sign. And then what we're going to be doing is determining on which side of that line all of our solutions lie, and which half plane all of our solutions lie. So we say that the green region is a half plane and the purple region is also a half plane, but we say that the half plane is the graph of the linear inequality that involves greater than or less than. It says the graph of a linear inequality that involves a greater than or equal to or less than or equal to is the half plane and the line in between. So you can see up here in this green half plane, they're saying that all of the points, say for instance the point 2 comma 5, which is in this green half plane, all the points in this half plane, when you substitute them back into this inequality, give us a true statement. So for instance, with the point 2, 5, we would get this value here that says, hey, 2 plus 5 is greater than 2, which 7 is definitely greater than 2. And so, of course, we would shade this way to shade all the solutions to x plus y is greater than 2. But you can see that if x plus y is less than 2, all we're really doing is referring to all of the points that lie in this little purple region down here. So to denote a few things here, it says a solid line is used to show that a line is part of the solution set, and a dashed line is used to show that a line is not part of a solution set. So when we talk about this graph right here, we just need to remember that if it's less than or greater than, we're going to use a dashed line when we graph it, okay? Which means we won't actually include all the points on that line. And if we use a less than or equal to or greater than or equal to, we're going to use a solid line. So the idea is that we're going to be graphing inequalities, and once we graph an inequality, we have to shade one side or the other of the graph here. And so we're going to look at how we might graph a linear inequality in two variables in a series of steps here. But it says, first thing we want to do is essentially this: replace the inequality symbol with an equal sign and graph the corresponding linear equation. So with respect to this video, we're going to be looking at only linear inequalities. But looking at this first graph here, it says 2x minus 3y is greater than or equal to 6. The first thing we're going to do is replace that greater than or equal to with just an equals, and we're going to go graph this right here. So now notice that this is in standard form, and because it's in standard form, how we're going to graph this is to graph it by finding its intercepts. So when a line is in standard form like this, let's go ahead and plug in 0 for x and solve for y. If we were to do that, we'd get 2 times 0 minus 3y equals 6. In other words, negative 3y equals 6 if and only if y equals negative 2. And if we were to plug in 0 for now y, we say 2x minus 3 times 0 is 6. We get 2x equals 6, and so x equals 3. So by knowing these two intercepts here, we'd say our x-intercept hits at 3, okay, and our y-intercept hits at negative 2. We could graph the rest of this line. Now, notice that it says draw a solid line if the original inequality contains a less than or equal to or greater than or equal to symbol, but we'll draw a dashed line if the original inequality is just less than or just greater than symbols. So in this case, we have a greater than or equal to, which would imply that we're actually going to connect these dots with a solid line. And we'd say that this right here, just to be clear on this, what I expect is that we'll always label this line with the equation. And so by equation, what I mean is we're going to call this 2x minus 3y. We're going to write equals 6, because all of these points on this line right now are the solutions to this equation. Now, what we're actually doing is actually graphing the inequality, but for labeling purposes, we just label this with the equation to say that these are all the points on the line. So what we're going to do now is this. We're going to choose what we call a test point. And when they mention a test point here, they say from one of the half planes. So to be very clear on this, it says don't choose a point on the line. What we're going to do is choose a point that is not on this line. And next, what we'll do is substitute those coordinates of that test point into the inequality. Essentially, what we're testing for is this. Can I find a point that's clearly on one side or the other that when I plug it in gives us either a true or a false statement? So the easiest point that I can think of that is not on this line, and what I'm going to tell you is the easiest point that, if you can help it, that is not on that line. If it's ever 0, 0, use 0, 0. And what we're going to do is we're going to substitute these coordinates of the test point into the original inequality. So our original inequality, 2x minus 3y, is greater than or equal to 6 here, greater than or equal to 6. If we were to plug in now this point 0, 0, you could see that anything in standard form, the whole left side is just going to become a 0. And so what we get really is the statement that says 0 is greater than or equal to 6, which this is a false statement. I'm even going to write false here. And so what we would say is that 0, 0 is not a solution. And because it's not a solution, remember that on a graph we only shade things that are solutions. And so since it was on, I suppose we would say, above the line here, since it was above the line and it is false, it provides us with the false statement. What that means is essentially is this, then all of the points on this side are false, because all the solutions are going to lie on one side or the other. So with step 3 here, it says if it's a true statement resulting, then shade the half plane containing the true statement. If a false statement results, shade the half plane not containing this test point. So essentially, since this was false, what we're saying is everything on this side of this, I guess, linear inequality is false. So what we're going to do is we're going to shade this half plane down here. And so one way you'll see this done is often you'll see people shade like this. I'm of the persuasion that we should just put little arrows this way saying that, hey, all of the solutions lie on this side. But this would be the set of all solutions to our linear inequality here. So what I want you to do before you tune out of this video is this. I want you to graph this as if there were an equal sign here first and label it, but then choose a test point, plug it into here and see if you get a true or false statement, and shade the appropriate side of the graph that corresponds to the solutions of this inequality. Cheers.